the standard deviation. So that's what we are saying. We are putting that formula. And we said that when you transform your scores in a distribution into standard scores, then one standard deviation above the mean is equal to 1, and one standard deviation below the mean is equal to -1. The mean itself becomes 0 in that distribution. Of course, I also mentioned that since we are talking about positions, and especially, for example, those of you in education, these positions might be talking about marks 8. Somebody has obtained 50 marks. The mean is 60. So 50 minus 60 is -10 divided by, let's say, the standard deviation of 10. So this person is described as a -1, and that's why another formula was computed, which is where you added 10 into all the measures so that you remove the characteristic of describing somebody with negative figures. So what I was talking about last time here, which is the mean, will always be 0. This, which is one standard deviation above the mean, will always be 1. This, which is one standard deviation below the mean, will always be -1. 2 standard deviations below the mean will be -2. 2 standard deviations above the mean will be 2. 3 will be -3, and 3 that side will be -3 there will be +3. 3 the other side will be -3. This is supposed to be a new thing, eh? So that's the mean, eh? Which is 0. Negative 1 standard deviation, positive 1 standard deviation, which is 1, -1, eh? That's what we're saying. 2 standard deviations will be 2, -2 standard deviations will be -2. Okay? -3 standard deviations is equal to -3 plus 3 standard deviations is equal to 3. Okay? And when you compute the proportion of scores within this area, they'll always come to 34.13. Similarly, in this area. Uh, so this area will contain 34.13% of the scores. Let's assume that you administered an exam to 100 students, okay? And you obtained a mean mark, their performance, the mean was 50, okay? Just assuming, and you computed the standard deviation and found that that standard deviation is 10. So this position will mean where somebody has got 60%. The number of students who will have performed between 50 and 60 will be 34% of the whole group. Am I making sense? So this one will be 34%. This will also be 34.13%. Those who perform within this area between 60 and 70. Sinaga 70 will be two standard deviations. There will be 13. I'm including my own numbers. 13.53. So this will be 13.53%. So true in this area, you have 13.53%. One of your colleagues in the weekend session said, where are you taking these numbers from? These have been computed by statisticians over and over and over, and they have found the same. One guy who is very well known as a statistician is Fisher. So he started this theory and found that, yes, it always comes to that percentage. That's why earlier on I was saying that when you are doing frequency distributions, the most liked curve is the normal curve because it has these characteristics. So if you don't have extreme scores, the scores are normally distributed. This is what you will find in the distribution. Actually, you also hear people talk about using larger sample sizes when you're sampling from a population to do your study. Because by using the larger sample size, normally you will be getting a distribution which is normal. Than when you have a smaller sample size, that's when you tend to experience too much of these extreme scores. And this area will contain 2.15. So through 2.15. That table I've distributed is actually based on this theory. If you look at you see the column which says Z. The first column is saying Z8. Look at the point where Z equals 1.00. Have you found that? 1.00. Page 2 towards the bottom, eh? And then the second column next to that, which says area between the mean and the Z. You're seeing that? It shows 0.3413. Right? Under z-score 1.00, the area between the z-score and the mean has 0.3413. You can't get those corners. Yeah, you see 1.00 here? This is 0.3413. 1.00, this one is 0.3413. That's what I'm referring to. This one. No. The next page. 1.00, 0.3413. 1.00, 0.3413. That's what I'm referring to. Yeah. That 0.3413 is this. 34.13. Okay? What that table is showing you that this area, it says between Z and the mean, between Z, which is 1, and the mean. This area contains a proportion of scores which is 0.3413. So if you assume that all the scores below this are 1/8, so the proportion you have within this is 0.3413. And if you convert 0.3413 into percentages, so don't get confused. You have the guide? If I were you, I took this from the internet. Now to fit in the numbers, I'm having problems. So you can draw that to be reminding yourself. But you can use the standard tables, they will also show you. Similarly, if you went at z-score 2, the area between the z-score and the mean will be 0.3413 plus 0.1353, which is coming to 0.47 something, 0.4772. Unaiona it? Unaiona mimi hiyo 0.4772. When you go to z-score 2, have you found where z-score 2 is? It's not there. Eh? 4772. Where z-score 2 is? This score 2 is this one, eh? No, z down 2.00. So 0.4772. Have you found it? Yes, true. That one. Found it? Not found it. No, you're on a wrong page. 2 is somewhere here. You see z 2.4772.
Is this one?
Yeah. You found it, eh? Uh-huh. So it means that this area plus this area, you have 47.72% of the observations. Are we okay? Eh? I'm not hearing. Is that called complaint or happiness? Complaint. Yeah, speak it up so that we deal with it. You're just seeing the numbers. Yes. Look here. The 2.00, which they are referring to there, is this 2, which I was showing you here. Okay? And what the table is telling you is that the area between the mean and the 2, so it's this area, it is containing 0.4772 proportion of the observations, which is 47.72% of all the scores will be found within that. Okay? Happy? At the back? Yeah, not really. Yeah. Look at me. I know I've given you the tables, but look, because I've shown you where to find the number in the table. Wait. Do you see the top of those columns, right? It says Z, and the next column says area between Z and the mean, right? Which is saying the area. You remember the mean is Z, right? And we have found that from that table, Z is 2, eh? So the area between the mean and the 2 z-score This area 8 contains 0.4772 of the observations, or 47.72 of the observations. So if you had given an exam to 100 students and you found that the mean performance in that exam was 50, the standard deviation was 10, okay? Then at the point it means somebody who has performed the 50 plus 10 plus 10, 70%. The person who has performed the 70% will have beaten those people who have performed at the mean point to where he has performed. 47% of the students will be within there. Okay? Meaning that if somebody got 70, how many students will have performed below him or below her? Apa apeza 47.728. Duty 47 students will be within this area 8. But then from 0 going that way will be 50% of the students 8. So 50 students will be there, and then 47 students will be there. So this guy has beaten 50 plus 47 students. Ndakutaya kwambiri. Yeah? Yosavuta. Sizikumveka pamene bweya. Siwapeza 70. Ayabeti. Koma mukuziwa kuti amene akhoza between the mean and the 70 are 47 students 8. Amene akhoza between the mean and the minus 1 standard deviation are 34 8. Amene akhoza between 1 standard deviation and 2 standard deviations below the mean, the 13 8. So mukukuchirada amene, right? Amene akhoza below that 2.15. So you can actually compute kuti uyu wapeza 70 yu amene wawaposera mkalasimo ndiwo sawa iti ukukuku kuli 50% ndi awa 47. Zikusokoneza zimene zikumveka iti looking in the air. Okay, let's try another one. From my example, and we are assuming that the mean is 50%, and the number of students is 100, and the standard deviation is 10. I've chosen 10 because it's easier to compute it. If somebody got 30% in this exam, how many students will he have beaten? If somebody got 30% in the exam, waposera ma students angati mkalasi ngene? 4? werenga nenewo ndiangati wawaposera. %30 how many standard deviations below the mean? $2,000 kwachiripo tu nandiyanke fosonayo tiika kweti yakhani kudikira inorerei ngati klasi imene iyi wina wapeza 30%. Amene wawaposera klasi imene ndi angati? Bwera muzaonesa apa mwepeza bwanji zida zonse muli nazo tu pamenepo zoipezereti ya ibwerere 2000 nthumba isabwerere. Okay, kodi 30% in this case is how many standard deviations below the mean? Yabwerera formula yake ni yetu pajamini tinati ncha mini tinati ncha a 0 standard in terms of the standard score 8, comma from the example I gave, mean yo immediately 0 yo is 50%. Okay, so this is 50%. Student representative 30, then put 30 minus 50 divided by sindikuvai standard deviation ndibwanji tinati bwanji standard deviation yacho 10, which is divided by 10, which is equal to minus 20 divided by 10, which is equal to minus 2. Ndiye kuti mkulu amene yuyu score yake ili apeti amene ali pakati pa iyeyo ndi mini ndi angati? Amene akhoza mamarks oti ali pakati pa iyeyu, amene akhoza mamarks pakati pa 30 ndi 50 ndi angati? Namba latu ndi awa 13.53 plus sina ngati kuti between apa ndi pamene paiti 13.53 ndi apa iti ndi amene amubita amene yuyu chifukwa choti apeza 31, 33, 34, 35 up to 50. They are 13.53 plus 34.13. Amene akhoza below 30 ndi angati? Yeah, 2.15. Of course, ukuku below the 3 standard deviations ali konswena umene kukwete. I mean in the 0.13. Mukachita add 0.13, 2.15, 13.53, 34.13 mpeza kuti fit. So, wauyu amene wapeza 30%, amene wawaposera ndi 2.15 plus 1 plus 0.13, which is basically 2. Maito right? Wina wake anachula 2 koma nangolota ndiye 2000 koma 2000 akanatha kuilongosola ndikanampasa ulo akanangonena kuti athu uyo basi. Yeah? Is it making sense now? You can, in other ways, you can use these standard scores for reading proportions of scores under this scale. That's what we are saying. And that table I've given you is giving you those proportions. Okay? Motifunso langa liya mukanathanso kuwerenga kungowerenga pakundipasa tatiyeni pamene pali 2 z-score 2 mwayiona z-score 2 yet. Go to the extreme column number 3 under z-score 2. It says the area in the smaller portion, meaning if you look at that, this is the bigger portion. The area between the mean and the score is the bigger portion. But as you're going that way, this area is the smaller portion. That's what is meant by that table. So in the area below, in the smaller portion, how many observations are there according to the table? Yeah. If you converted that into percentage, it will be 2.28. Muyang'ane pa paper 2. Wait. Look at the third column. At the third column is 0.0228. If you multiply that by 100 to get percentage, it will be 2.28. So and that's if you add 2.15 plus 0.13 is equal to 2.28. Is that now making sense? Okay. If somebody using the same assumption, you have 100 students, 100 students, they have written your exam in mathematics, and you have computed the mean performance of these students. It comes to 50%. And you have also computed the standard deviation. it comes to 10. If somebody has obtained a mark of 75, let's start with a mark of 80%. How many students has he beaten in this class? How many students have scored below him in this class? Eh? Okay, ndikupasa ndalama koma ndalama ake sikhala imene ijasopa ija inachuluka nakasita kuonesa machitidwe ake ndiye tigwesa 500 apo iyo si odi buleza sufuso. Number of students in it 100. Mean score 50%. John's score 80%. How many has he beaten? Yeah. Standard deviation 10. How many are below him? Three. Mwaipeza bwana. Sinathenkani mwaenda bwino ndithu kwambiri koma 500 simunaisirize kaya isirize simufuna 500 ndiye ndikaninazo ndiye 500 mukandilola kuti 500 iwire nthumba ndikuwuzani kuti asiwa muchitiri mutere koma mwaenda bwino ndithu mwafika pena pake kuti mwasala pang'ono kusiriza mtundawo mwachoka ku Lilongwe mwakafika mpaka na ku Chikangawa. You just have won the last leg to get to Mzuzu. Hmm? 100. Amene wachita biti ndi angati? Eh? 99. How did he get 99? Yeah, wachita biti osauko. Ndi wachita biti 99. Sana wachita biti 99 itu. Last time before it goes into the pocket. Yeah? What bit of 5? How have you found the 5? Yo, Francisco ya 3. Ye Francisco ya 3 mwapeza kuti can you come and show here? Come and explain.
Naweza kwenda hiyo. Navanga ifide nini minus 8 which is negative
500 yandikira komosa ile pere tu. Wisirize.
Negative divided by generalization negative 3. Negative 3 au general ba general
Ibwerere trumbaite.
Kurengera n'ogene yacu naboneka bamama aba which is 0.13 what is 2 what is
Kama mwesa koma simuna isirize unakodwa. There are two ways you could have done it. It's just a question. Like I said, added all these in. All these are below him, right? Or 100, the one you were using, you found the lower, smaller side of weight. The 100 minus that smaller side will give you what you needed to get. Ndiye uwagaira zako paje unapeza negative 3 tu hiyo. Wina wake anakuuza kuti ni positive 3. Ndiye muona kume ungaira minuti. Okay, that was a game. Wait. Now do this one. A substantive one for you. You know, this, I would really want you to understand this concept, because it is a very essential concept in statistics. It's the concept which we use for assessing whether if you have true distributions and there is a difference of the mean. Maybe one mean is 60%, the other mean is 50%. And the question is, are these two means different or not? We use this concept. So I really want you to get used to this process. Let's assume you have a class size of 500 students. You made them write an exam in introduction to applied statistics or educational statistics. And John, in this exam, got 78%. The mean performance of these students in this exam is 65%. With a standard deviation of 6. How many students will John have beaten in this class? How many students will have performed below John in this class? Of course, you have some 10 minutes. You can go, you can stretch, but when you come back, work it out and give me. Still working on it. Kamaliza. Everybody correct us. Professor. Professor Cole is choosing to have equipment. One. Yeah, so the question is how many students has he given? So how many are they? You got 452.
Yeah, yes. It is 451.5.
No se monte de video. Seventy-eight minus 65 divided by 6 was correct by our formula. And having gotten that was correct. But what you were supposed to do with this is to read in your tables.
Yes, we did. That's where we get 48 and 50.
Yes. Because what is this for 8.5? It's the proportion of the students from the Z score of John to the minute. So those who got